In this video, we'll be discussing section 7.8 from chapter 7 of P4, and the section discusses 3D coordinates and 3D distances. Okay, so we did discuss this 3D coordinates and 3D distances in our previous section, so it will be more or less a revision over here. Okay, so again, 3D coordinates are on a 3D space, so we do have an x-axis, a y-axis, and a z-axis that points up into the air. Okay, so an x-axis, a y-axis, and a z-axis, and all the axes are at 90 degrees to each other. All the axes are at 90 degrees to each other. Okay, x is at 90 degrees with y is at 90 degrees with z, and z is at 90 degrees with x. Okay, and if we do have a point, let's consider a point P, which has coordinates x comma y comma z. That's x1 comma y1 comma z1. Okay, and we have the origin O for the 3D coordinate space. Okay, and you want to find the distance OP. In that case, it is going to be simply the Pythagoras theorem in 3 dimensions. Okay, and we are going to use the Pythagoras theorem in 3 dimensions, and that gives us the distance OP. The distance OP is equal to root of x square plus y square plus z square. Okay, it's simply the Pythagoras theorem in 3 dimensions. We thus have 3 components over here: x square plus y square plus z square, the whole root. Okay, if we do have another point, let's consider we have a point P over here. Okay, that has got coordinates x2 comma y2 comma z2. Okay, and we want to find out the distance PT. Okay, so PT, the distance PT can be found out simply we'll be using a 3D version of the formula that you learned for 2D geometry back in P2. So it will be simply the differences of the coordinates, and each of the differences are squared. So okay, so x1 minus x to the whole square plus y1 minus y to the whole square plus z1 minus z to the whole square and the whole square root. Okay, so nothing different from what we had studied earlier. It's just that we have a third component over here because of the z axis that we have. Okay, so now let's consider an example. In this example, we'll be solving the challenge question on page 125. Okay, on page 125 we have a challenge question after exercise 7H, and this challenge question will be in the first part of the question says that we have points A, which has points A, B, and C. A has coordinates 1, 3, minus 2. B has coordinates 1, 3, 4, and C has coordinates 7, minus 3, 4. Okay, and they are the 3 vertices of a solid cube. Okay, so we have a solid cube. Okay, and they are asking us to find the coordinates of the remaining vertices. Okay, so since it is a cube, okay, since it is a cube, minus 2, we have 1,3,4. I mean, it does not matter actually where C is being placed over here for the time being. Okay, but we are asked to find the remaining 5 vertices. Okay, so but actually it does matter. Let's find out. Okay, so we have 1, 3, minus 2. We have 1, 3, 4. Okay, so notice that for A and B, 1 and 3 are the same. We just have one coordinate that changes. Therefore, A and B are lying more or less on the same line. Okay, A and B are lying on the same line. Okay, so this is 1, 3, minus 2. This is 1, 3, 4. Okay, now since this is 1, 3, minus 2, this is 1, 3, 4. Okay, all these points are going to have z coordinate 4. Okay, all these points are going to have z coordinate 4. And all these points are going to have z coordinate -2. We do have another point over here. Okay, these are all rough sketches. Okay, so and since 4 C has a z coordinate 4, it is going to be one of these 4 points over here. Okay, one of these 4 points over here. So let's get C back over here. Okay, let's get C back over here, and we can to find out the other okay, let's try to find out whether does C lie over here, here or here. Okay, to find out whether C lies over here or here or here, we do need to find the distances over here. So what is AB? Okay, the distance AB, okay, and the distance AB is equal to 1 minus 1 the whole square, which is 0 square, 3 minus 3 the whole square, which is 0 square, plus 4 minus of -2 the whole square, which is plus 6 square, and that is going to be overall 6 units. Okay, notice that the distance for AB is equal to 6 units. Okay, 4 minus -2 the whole square is equal to 4 minus -2, which is 6 the whole square, the whole root is going to be equal to 6. So this is 6 units, and notice that the question says that this entire thing is a cube. Okay, so since this entire thing is a cube, okay, all sides are having length 6 units. Okay, so this side is 6, this side is 6, this side is 6, and so on. Let's try to find out the distance BC and AC. Okay, and find out let's find out what AC is in the first place. Okay, AC is going to be equal to 7 minus 1 the whole square, which is 6 square, minus 3 minus 3 minus 3 minus 3 the whole square, which is minus 6 square, minus 6 the whole square, 4 minus -2 the whole square, which is 6 square. Okay, and this is going to be equal to 6 times √3. Okay, notice that this is not equal to 6. Therefore, A and C are not along the same edge. Okay, A and C cannot lie along the same edge. Okay, so so in that case, if we talk about A and all the edges that are connecting to it, we have one edge here, so this is definitely not C. We have one edge here, that is B. Okay, we have one edge here, and that is also not going to be C. Okay, C can be any of the other ones. Okay, let's talk about BC then. Okay, BC is equal to 7 minus 1 the whole square, which is 6 square, minus 3 minus 3 the whole square, which is again 6 square. Okay, and then 4 minus 4 the whole square, which is 0 square, and that is equal to 6 √2. Okay, so 6 √2. Notice that this is also not equal to 6, and therefore since 6 √2 is not equal to 6, okay, B and C do not lie along the same edge. Okay, so B and C, this is one of the edges connecting B. C is definitely not this point. B and A are not along the same edge. B over here we have A, so definitely this one cannot be C. We have this edge, and that is definitely not C either. Okay, so that is definitely not C either, and therefore the only point left after taking into consideration that this is not C, this is not C, this is not C, this is not C. Okay, we have 2 points over here left, this C and this C. Okay, let's redraw the diagram actually. Okay, okay, so since AB is equal to 6 but AC is not equal to 6, therefore this point is out, this point is out. Okay, because this was A. Okay, the A and C are not along the same edge. Okay, and for B, since BC is not equal to 6 either, therefore this point is out this point is out. Okay, now we have one point over here. This is one option number one. Option number two, we have two options left. Okay, notice that AC is equal to 6 root 3, 6 times root 3. Okay, we have three components of 6. So there is a x difference of 6, there is a y difference of 6, there is a z difference of 6. So you have an x difference of 6, a y difference of 6, and a z difference of 6. Okay, and over here we have only 6 root 2. Okay, we have two differences of 6. Okay, an x difference of 6 and a y difference of 6. There is no z difference of 6. So we have 6 and 6, two differences of 6. So therefore this is going to be C. Okay, we do not need to worry about the exact orientation, which way x is pointing, which way y is pointing, which way z is pointing. As long as you can get a rough figure, it's okay. Okay, so C is definitely this point over here, and it is the point across B. Alright, so now we need to find out the remaining 5 vertices. Okay, so to find the remaining 5 vertices, let's note them down. We have got D, we have got E, we have got F, we have got G, and you've got H. Okay, so first part is going to be we know what AB is. Okay, what is AB? We know what AB is. AB is equal to simply OB. AB is equal to simply minus OA plus OB. Okay, it is equal to BO plus OA. AO plus OB. Okay, AO is equal to minus OA, therefore minus OA plus OB. What is O minus OA? Okay, 1, 3 minus 2, therefore minus OA is going to be equal to minus 1, minus 3, 2. OB is going to be equal to 1, 3, 4. And therefore AB is therefore equal to simply the addition of these two vectors. You get 0, 0, 6. Okay, 0, 0, 6 makes sense because our AB has length 6 units. Therefore AB should have length, the vector AB should have length 6 units. Alright, so you have 6 over here. Notice the figure over here. We have AB as 6 units. What is EC then? Okay, EC is therefore also the same as AB. Okay, from a figure we notice that EC is equal to the same as AB. Okay, EC is the same as AB, and therefore since EC is equal to the same as AB, in that case EC is also equal to 0, 0, 6. Okay, now let's break down EC. What is EC? Okay, EC is equal to EO plus OC, EO plus OC, which can be written down as minus OE plus OC, and that is equal to 0, 0, 6. Okay, now let's take OC to the other side. Let's rearrange this equation. Let's take OE to the other side and that one to the side. So we get OE is equal to OC minus 0, 0, 6. Okay, so OE is equal to OC minus 0, 0, 6, and OC, we know the coordinates for C, 7, minus 3, 4. Substitute that, we get 7, minus 3, 4, minus 0, 0, 6. Okay, and that is equal to 7, minus 3, minus 2. Okay, 7 minus 3 minus 2, and that's your coordinate for 7 minus 3. Yeah, 7 minus 3 minus 2, that's your coordinate over here. 7 minus 3 minus 2. Okay, notice that our initial assumption is actually still holding true. Its z coordinate is minus 2. Okay, all these three are going to have coordinate minus 2. So you got E now. Okay, we done with E. Now let's try to find out the next coordinate. Okay, the next coordinate we do know that FH is also equal to AB. FH is also equal to AB. Okay, and we did our initial deduction that f has z coordinate -2. Okay, what else does the question have? Okay, notice other similarities over here. Okay, that since A and B share their x and y coordinates. Okay, so since A and B share their x and y coordinates, both A has coordinate 1 and 3, B has coordinate 1 and 3. Okay, so A and B share their x and y coordinates, and in a similar fashion, E and C also share their x and y coordinates. C has 7 minus 3, E has 7 minus 3. Okay, and in a similar fashion, okay, F and H are also going to share their x and y coordinates, and so are D and G. Okay, they're also going to share their x and y coordinates. On the other hand, B, H, C and G are sharing their z coordinates. Okay, B, H, C and G are sharing their z coordinates. Okay, and B, H, C and G are sharing z coordinates, and A, F, E and D are sharing the z coordinates. For all these points over here, they have z coordinate -2. All these coordinates over here, they have z coordinate 4. Okay, now we do need, okay, let's consider point D over here. Okay, let's consider point D. Okay, and let D have so since from our pattern we can see that D has coordinates. Let's give it some random coordinates E, F, and we do know that the z coordinate is -2. Okay, so E, F, -2. Okay, and you do know, okay, so -2 is because of the fact that all these coordinates over here on the bottom are having z coordinate -2. All the coordinates on the top are having z coordinate 4. Okay, so D has coordinates E, F, -2, and you do know that the distance AD is equal to 6. Okay, because it is along the edge of the cube, and you also do know that D is equal to 6. Okay, so AD is equal to 6, D is equal to 6, and therefore you can construct two separate equations. Okay, so let's consider the equations for AD. Okay, for AD the equation is going to be E minus 1 the whole square, E minus 1 the whole square, plus F minus 3 the whole square, F minus 3 the whole square, -2 minus 2 the whole square is going to be 0 because they are both sharing the z coordinate. Okay, this is equal to 6. This is equal to 6. If I remove the square root, in that case this becomes 6 square, which is 36. Okay, in a similar fashion for DE we can write this a second equation, and for D we get E minus 7 because that's the position vector for E. Okay, so E minus 7 the whole square plus F plus 3 the whole square, F plus 3 the whole square, and then D and D share the z coordinate -2 minus 2. Okay, therefore -2 minus 2, since they're sharing this coordinate, this is going to be equal to the z coordinate difference is going to be 0, so that term cancels out. Okay, root of this answer gives you 6. Cancel out the root, we get 6 squared, and that is equal to 36. Okay, so you do have two equations now. Okay, E minus 1 the whole square plus F minus 3 the whole square equals 36, and E minus 7 the whole square plus F plus 3 the whole square is equal to 36. Notice that in this equation we having two separate answers. Okay, now let's try to find out the answer for both of these equations. Okay, we do have quadratics over here. Okay, we can write this down as let's expand this expression over here. E square minus 2e plus 1 plus f square minus 6f plus 9 is equal to 36. And for the second one, you get e square minus 14e plus 49 plus f square minus, f square plus 6f plus 9 is equal to what? Is equal to 36. Okay, now we do have two equations. Let's subtract the second equation from the first equation. Okay, so we get e square, the entire equation is getting subtracted. Okay, so we get e square minus e square is simply 0, minus 2e minus 14e is 12e. Okay, so minus 2e minus 14e is 12e. Okay, plus 1 plus 49, and plus 1 minus 49 is minus 48. F square minus f square cancels out, minus 6f minus 6f is minus 12f, plus 9 minus 9 cancels out, we get 36 minus 36 cancels out, we get this expression over here. Okay, in other words, we get an expression for e. Okay, and the expression for e that you're getting is 12e minus 48 minus 12f is equal to 0. Therefore, e minus 4 minus f is equal to 0, or in other words, e is equal to f plus 4. Okay, e is equal to f plus 4. Okay, substitute e is equal to f plus 4. Substitute this back to our very first equation over here. Okay, e is equal to f plus 4. Substitute this back into the very first equation we have over here. We get e is equal to f plus 4. So this becomes f plus 3. Okay, f plus 3 the whole square plus f minus 3 the whole square is equal to 36. Okay, solve this equation to find f, and then we can find out e. Okay, so f plus 3 the whole square plus f minus 3 the whole square equals 36. We get f square plus 9 6f plus 9 plus f square minus 6f plus 9 is equal to 36. Okay, 6f and minus 6f cancel out each other. We get 2f square is equal to 18. Okay, plus 9 cancel, goes to the other side, you get 18, and if f square equals 9, f is equal to therefore plus minus root 3, plus minus 3, excuse me. Okay, plus minus 3. Now e is equal to f plus 4. Okay, so e is equal to f plus 4, and therefore when f equals plus 3, when f equals plus 3, we get e is equal to 7, and when f equals minus 3, we get e is equal to 1. So we got two different answers. Notice that we did get two different answers, and it does make sense because in our solution we tried to use d. Okay, and we found an expression for AD, and we found an expression for DE. But the thing is, we could actually use the same reasoning, the same equations for AF and FE. Okay, and have found the same answer. Okay, so AF and FE, if we did find an expression for AF and did find an expression for FE, okay, we would have got the same answer. So in other words, one of this is going to be for D, one of them is going to be for F. Okay, now in our particular situation, does it matter whether D and F, which one is D and which one is F? It actually does not matter. Okay, the question does not specify specifically what D is, what F is, what G is, what H is. Okay, and therefore you can choose anything. So let's consider, let's have D have these coordinates, and let F have these coordinates. Okay, so therefore in this case, D is going to have then coordinates E comma F comma minus 2. So this is going to be 7 3 minus 2. Okay, what about F then? Okay, F is going to have coordinates 1 comma minus 3 comma minus 2. Okay, 1 comma minus 3 comma minus 2. Now we have H and G. Okay, since we did, or in our previous discussion when we were discussing, we knew that since A and B have the same x and y coordinates, D and G are going to have the same x and y coordinates. Therefore G is going to have 7 comma 3, and G has the same z coordinate as this 4 points. So B and C have z coordinate 4, therefore G also has z coordinate 4. Okay, and for H, it's going to have the same x and y coordinate as F, 1 comma minus 3, and the z coordinate is going to be the same as that of B and C, that is going to be 4. And there you go, with we have D, F, G, H. We had E over here. Okay, E is 7 minus 3 minus 2, and D, E, F, G, H. Yeah, we are done with all the points. We have A, B, and C in the question, and the remaining 5 points D, E, F, G, and H are over here in this. I have been found out here over here. Now we do have another part of this question, and in this question they're asking us to find. Okay, so we have an ant in this example. Okay, we have an ant that moves from A to C along the surface of the cube. Okay, we have an ant that moves along the that moves from A to C along the surface of the cube, and you need to find out the shortest possible route that the ant can take. Okay, the shortest possible route the ant can take. Now, okay, let's redraw the cube for simplicity again. We have the cube. We have A here, we have C here, and the ant is going to take is going to move from A to C, and is going to take the shortest route. Now, the shortest route it could be the shortest route could be. I mean, what are the possible routes for A and C? From A to C, it could take any particular route. Okay, it could even take routes along the other faces that we're not seeing right now. Okay, but the shortest route is going to be from A. Okay, if it travels from this surface to the other surface. Okay, in that case we can transfer. It can move from A to the midpoint of this line over here, and then from the midpoint it can go to C. That is going to be the shortest route. Okay, in straight lines. On the other hand, if it travels from this face to this face, A till the midpoint of this, and then from the midpoint over here till C, that's going to be the shortest route. On the other hand, it could also take from A, if it travels this face and this face, to the midpoint over here. Okay, this is the back and this is the bottom face. Okay, to the midpoint over here, and on the back face it could travel to C. Or it could travel the left face and the back face from A till the midpoint of this very back edge, and then from there it could travel to C. Okay, so there are 4 possible routes, but in all the cases it is going to travel first to the midpoint of one of the edges, and then from there it is going to travel to C. Okay, that is the only possible way that it can have the shortest possible route. Okay, so let's consider over here this point. Okay, the midpoint, and let's consider the route, the shortest route. The shortest route is this. Okay, the midpoint, and the shortest route is going to be a straight line between the 2 points. Okay, and to find this length, we do know that the length of the edge is 6 units. In that case, the length of half the edge is going to be 3 units, and therefore the length of this route, half of the route, is going to be root of 6 square plus 3 square, simply using the Pythagoras theorem, and therefore that is going to be equal to 3 root 5. Okay, and that's just half the route. We have another half of the route that is going to follow the same pattern, and therefore it is going to be the entire route is going to be 2 times half the route, 2 times 3 root 5, and therefore it is going to be 6 root 5 units. Okay, that's the shortest possible route that the ant can take.